Europa has fascinated scientists for decades. Beneath its cracked, frozen surface lies an ocean larger than all of Earth's oceans combined. This makes Europa one of the most promising places to search for life beyond our planet. But studying that ocean has always faced one impossible obstacle. A shell of ice, possibly tens of kilometers thick, blocks any direct access. For years, this frozen barrier stopped humanity from answering one simple question: what is really happening beneath Europa's surface? The ice covering Europa is not smooth or simple. It is constantly fractured, reshaped by Jupiter's gravity, and exposed to intense radiation. Any lander or drill sent to Europa would need to survive extreme cold, crushing pressure, and powerful radiation storms. Traditional drilling methods fail long before reaching the ocean below. As a result, Europa's subsurface remained hidden, turning the moon into one of the most frustrating mysteries in planetary science. Scientists knew that if life existed on Europa, it would likely be in the ocean beneath the ice. That ocean is heated by tidal forces from Jupiter, keeping it liquid despite the freezing environment. Chemical interactions between water and Europa's rocky core could create conditions similar to Earth's deep-sea hydrothermal vents. But without reaching the ocean or even seeing it clearly, these ideas remain theoretical, with no direct evidence to confirm them. For years, missions focused only on Europa's surface. Spacecraft photographed cracks, ridges, and strange chaotic terrains. These features hinted that water from below might occasionally rise closer to the surface, but hints were not enough. Scientists needed a way to study the ocean without drilling through kilometers of ice. The biggest problem was clear: how do you explore an alien ocean you cannot physically reach? The breakthrough came when researchers stopped thinking about drilling and started thinking about signals. Instead of breaking through the ice, they asked whether Europa's ocean could reveal itself naturally. Ice, although thick, is not completely opaque to certain types of energy. By using advanced radar and electromagnetic techniques, scientists realized they could see through the ice and detect what lies beneath, without ever touching the surface. New radar instruments were designed to send powerful signals deep into Europa's ice shell. These signals behave differently when they encounter solid ice, liquid water, or salty brines. When the data returned, patterns began to emerge. Certain regions reflected signals in ways that could only be explained by liquid water beneath the ice. This was not speculation anymore. It was measurable, repeatable evidence pointing directly to Europa's hidden ocean. Even more surprising was what the signals revealed about the ice itself. In some regions, the ice appears much thinner than previously believed. In others, pockets of water may exist just a few kilometers below the surface. These subsurface lakes could act as bridges between the deep ocean and the surface. This discovery dramatically changed how scientists view Europa's structure and its potential to support life. The data also suggested that Europa's ocean is not calm and isolated. Instead, it is active, dynamic, and constantly interacting with the ice above it. Heat from below pushes water upward, while surface ice sinks back down. This circulation means nutrients and energy can move through the system, creating a stable environment where life could survive for millions, or even billions, of years. By solving the problem of accessing Europa's ocean indirectly, scientists unlocked a new way to explore icy worlds across the solar system. Moons like Enceladus, Ganymede, and Titan may be studied using similar techniques. The success of Europa's research proves that physical contact is no longer required to explore hidden oceans. Information can travel where machines cannot. This breakthrough also reshaped future missions. Instead of risking landers and drills, spacecraft can now focus on precision instruments and long-term observations. Missions like NASA Europa Clipper are designed to repeatedly scan the moon, mapping its ice and ocean in incredible detail. Each flyby adds another layer of understanding, slowly revealing the full complexity of this alien world. Europa is no longer just a frozen moon. It is now seen as an ocean world with active geology, chemical energy, and the essential ingredients for life. Scientists believe that if life exists anywhere beyond Earth in our solar system, Europa is one of the strongest candidates. The only thing missing is direct biological evidence, and now humanity is closer than ever to finding it. What makes this discovery even more important is its simplicity. No drilling, no landing, just physics, mathematics, and patience. By listening carefully to the signals returning from beneath Europa's ice, scientists turned an impossible barrier into a source of information. The ice that once blocked exploration became the key to understanding what lies below. This solution also changes how we think about exploration itself. Instead of forcing our way into alien environments, we can learn to read their natural signatures. Europa taught scientists that the universe often reveals its secrets quietly, waiting for the right tools and the right questions. The biggest obstacles sometimes hide the biggest answers. As technology improves, future missions may refine these techniques even further. High resolution radar, better data processing, and longer observation periods could one day map Europa's ocean currents, chemistry, and energy sources in detail. Each discovery brings us closer to answering one of humanity's oldest questions: are we alone? Europa's biggest problem was never the ice itself, it was our limited perspective. Once scientists changed how they approached the challenge, solutions emerged rapidly. The moon that once seemed unreachable is now one of the most understood ocean worlds beyond Earth. And this is only the beginning of what Europa has to reveal. By solving Europa's greatest obstacle, scientists didn't just unlock one moon's secrets. They opened a new chapter in space exploration, a future where hidden oceans are no longer beyond our reach, a future where life may be discovered without ever setting foot on alien ground. Europa didn't change. We did.